So this video, we are concentrating on section 10.3, which is solving quadratic equations by graphing. Now in 10.2, we talked about solving quadratics, and we used three ways to graph our equation. One was which we found the y-intercept. The second was we found the vertex, and the third was we found the axis of symmetry. Well, in this lesson, we're adding a fourth thing that we are going to use, and that is we are trying to determine the x-intercepts for our graphs. Now, when it comes to finding our x-intercepts, we can have either 1, 2, or no solutions. The graph that I have to our right here is an example of our x-intercepts that have two solutions. We have a crosses here at -3, 1, and right here at 1, 0. If you look in the literature, it should be a +1 and a -3. I apologize for the typo. And so we can determine that has two solutions. We could also have a graph that looks something sort of like this. And it has x-intercept here and here. We can also have an x-intercept that only has one solution, and it looks something very similar to this. And if it touches the x-axis right at the vertex, so if the vertex it happens to be the x-intercept, then that particular equation only has one solution for the x-intercept. The last one is no solution. No solution could look something sort of like this or something like this, where the graph doesn't even touch the x-axis. So let me erase all this and clean it up a little bit. So we're adding that fourth step to finding the x-intercept. How we do that mathematically, after we determine that it does have either one or two intercepts, let's use the example of y equals x squared plus 2x minus 3. What we do is we set y equal to 0, because if you look here, our y coordinates are shown up as 0. So let's go x squared plus 2x minus 3 equals 0. Now this looks like one of the trinomials that we had from chapter 9. So all we're going to do is we're going to factor these out. So we got the parentheses equals 0. I see that I have a -3, so that means that the signs will be different, and x and x, and I can determine that x plus 3 and x minus 1 will FOIL out correctly. And so we use the zero product property to find what x should equal. So x could equal -3 and x equals 1. And that shows up here and that shows up here. So we have to use those methods in order to solve quadratic equations. So for our first example, For our first example, y equals x squared plus 4x minus 21, we want to graph the equation. In order to do that, we must find those four things. the y-intercept, the vertex, the axis of symmetry, and if it has x-intercepts. So first off, I'm going to find out what our A, B, and C equal, just like from the day prior. So our A equals 1, our B equals 4, and our C equals negative 21. Our y-intercept is 0, comma, negative 21, because what we talked about in 10.2, it states that the y-intercept coincides with 0, comma, C, and our C is negative 21. So if we're looking at our graph, let's imagine that each grid from here to here is 5 units in measurement. So for C, for the y-intercept to be 0, comma, negative 21, so I got 5, 10, 15, 20, so I would say it's right about here. Now, to find our axis of symmetry, we have to use the equation x equals negative b over 2a. So then that equals negative 4 over 2 times 1, which is 2, and x equals a negative 2. So somewhere right around here. And our vertex, we know that the x-coordinate will be a negative 2, but the only way we can find out what the y-coordinate is by substituting in our negative 2 into our original equation. So if we go y equals negative 2 squared plus 4 times a negative 2 minus 21. So we have negative 2 squared is 4 minus 8 minus 21. So 4 minus 8 gives us a negative 4. Negative 4 minus 21 gives us y equals negative 25. So our vertex is at a negative 25. So we go 2, comma, so 5, 10, 15, 20, 25. So right about here is our vertex. So we found out our y-intercept. We found out our vertex. And since A is positive, we know that it's going in a upward direction, which is a minimum value. And we can tell that it's going to have 2 solutions for our x-intercepts. So what I'm going to do is I'm going to take x squared plus 4x minus 21 and set it equal to 0. So I'm going to factor this out. Got x and got x. I know it's going to be a plus. I know it's going to be a minus. And 7 and 3 will give me the correct values. So x equals negative 7 by using the zero product property, and x equals 3. So if we go right about here is where 0 comma or negative 7 comma 0 is, and right about here is where 3 comma 0 is located. Now it's just a matter of connecting our graph, and there is our graphed equation of y equals x squared plus 4x minus 21. Here's another. So if we look at it, again, we're going to find what our A, B, and C equal. We know that A is negative 1, we know B is 2, and C is negative 1. So each one of these squares is 1 unit in measure. So we know that initially our y-intercept is at 0 comma negative 1. And to find the axis of symmetry, we go negative b over 2a, which equals negative 2 over negative 2, which equals 1. So our vertex, we know that it's going to be at 1, comma, something. So we substitute in 1 in for x. So I have a negative 1 squared plus 2 over 1 minus 1. So we have y equals, so 1 squared is 1, but we have the negative, so that's a negative 1 plus 2 minus 1. So negative 1 plus 2 gives me a positive 1. 1 minus 1 gives me 0. So our vertex is at 1, comma 0. And if we were to find that, it is right about there. Now if we look at this, we have a vertex that touches the x-axis. So that means that our vertex is also the x-axis, which also means that it only has one solution. So I'm going to graph this. It looks something like this. We know that it is a downward direction because A is negative, and we don't necessarily have to solve for 0, and as long as we have the graph. If you wanted to solve for it and set y equal to 0, you can. You'll find that x will equal 1 for both properties, and you can double check if you'd like. Last one. So we have y equals x squared plus 2x plus 2. Let me drop the graph down a little bit. Okay. So my a equals 1, our b equals 2, and our c equals 2 also. So our y-intercept is at 0, comma 2, which is right about here. Find the axis of symmetry. We go x equals negative b over 2a, which then equals negative 2 over 2, which gives me a negative 1. And so in order to find the vertex, I know that the x value is negative 1, and our y value is what we can substitute negative 1 in for x, so negative 1 squared plus 2 over negative 1 plus 2. So y equals negative 2, or I'm sorry, negative 1 squared, which is 1. So we have 2 times a negative 1, which gives me a negative 2 plus 2. So 1 minus 2 gives me a negative 1. Negative 1 plus 2 is 1. So y equals 1. So our vertex will be at negative 1, comma 1, which is right about here. So now as I look, I notice that my vertex is in the second quadrant. My y-intercept is above my vertex, and I know that I'm going to have an upward direction in our parabola because A is positive. So draw it up like this, draw it up like this, and since our parabola does not cross the x-axis, we can determine that the x-intercept has no solution. And that is all for section 10.3. I hope this helped out. Until next time.